Okay, guys, welcome to the next session. I'll be talking here about a very important concept. Frequently, questions have been asked here. Name is thermal stress. Okay, thermal as itself meaning temperature. Correct? Now, we know when the temperature changes, it increases or decreases. In that case, the matter will expand or contract. Expand, there are two options: expand or contract. Now, by common sense, when will the matter expand? When there is an increase in the temperature. Similarly, when there is a decrease, the matter will contract. If it becomes cold, the substance shrinks. If it becomes hot, the substance will expand. Now, let's take a box here. Okay, maybe it is made up of steel, just assume. Okay, I have kept it. This is the floor here. Okay, I have just kept it here. Just simply on the floor I have kept it. Okay, now I increase the temperature. Okay, it will expand, right? Now it is expanding in all the directions, so one bigger cube will form. Okay, yeah, this is a changed size of the cube now. Okay, now if I ask you the question, what kind of stresses are induced in this box due to the change in the temperature? Okay, the answer will be straight away 0. Why? Let me explain. See here, the stress will be induced only if the body. What is the definition of stress? In the first chapter I have told, stress is nothing but the resisting force offered by the body against an external force. Correct? So here there is no obstructing force externally applying to the body such that there will be a resistance in the change in the direction. I mean to say, there is no obstruction to prevent the change in this direction or this direction, to prevent the change in the length or the dimensions of the box. Okay, if there was a wall at this point, or maybe this point or this direction, okay, in that case stresses will be induced in that direction where there is a wall which is obstructing the change in direction in that direction itself. Okay, but the other two ends, if suppose wall is there only at this end, in that case stress will be there only in this direction, but these two directions there won't be any stress because it is free to expand in that direction. There is no obstruction. Okay, if there is no wall at all, it is kept only at the floor and freely expanding, then in that case, if this word is used in the question, I hope you got the idea. Free expansion, in this case there won't be any thermal stresses induced in the box. Okay, now secondly, there is something called coefficient of thermal expansion. Okay, this is represented by alpha and the units will be per degree centigrade. Okay, now we have some set of formulas. Change in length is nothing but original length into alpha t or alpha delta t to be more precise. L is the change in length in any direction can be given by the original length in that direction into alpha, coefficient of thermal expansion, into change in the temperature. Okay, which is in centigrade, and this will be per degree centigrade. Centigrade cancelled. Length unit will be meter or mm. This will also be in meter per mm. So dimensionally also this equation satisfies. I'll write it again. So just remember this. This is important. First. Secondly, we have alpha into T, which is nothing but sigma T by E. This is nothing but strain. The strain induced due to increase in the temperature or decrease in the temperature. The strain is this. Strain, we know, sigma by E is called as strain. This is Young's modulus. We can write it the other way also. Thermal stress induced due to change in temperature is E alpha delta T. Yeah, just remember this formula. Okay, so this is the end of the session. Next we will be solving few problems based on this. So please go through the concept. If any doubts, please post in the comment section below. And thank you guys, and subscribe to my channel.